Hi, I'm Jon Sequeira. I'm the engineering lead for the .NET Interactive project.
Hi, I'm Diego Colombo, and I'm a software developer and engineer in the .NET Interactive team.
Hi, I'm Naggaga. I work at Microsoft, where we build interactive experiences for developers, such as .NET Interactive, which includes the .NET kernel. Thank you so much for watching our talk today on the lessons we learned while building a multi-language kernel. So let's get started. We're part of the .NET Interactive team, and .NET Interactive is an engine that enables people to write code in the context that matters to them. And we've been on a journey here, from online interactive documentation with Try.net to interactive offline documentation with our CLI tool, and our recent journey into Jupyter notebooks. When it came to Try.net, the purpose of this project was to bring .NET code closer to first-time developers and people new to our ecosystem, giving them a place where they could explore, learn, and run code in the browser. Our feedback here was really good. We had an overall better user experience, but we had a couple of drawbacks, which was transitioning to working locally was a bit of a challenge for people. We wanted to ensure that transitioning to working locally was easy. With a lot of documentation consisting of markdown files and full project samples, we wanted to unify the experiences using the .NET Try CLI tool. In this first image is a C# file, and you've noticed that I've highlighted a code snippet in C# region. In the next image, in a markdown file, I am referencing that region in a code block. And finally, using the .NET Try CLI tool, we can now run and edit our code in the browser. The purpose of the .NET Try CLI was to allow people to mix documentation with full projects and provide success for our users without having the need for an IDE or editor. We found that people were beginning to use this for documentation, workshops, and even presentations. And a couple people mentioned how it reminded them of Jupyter. And this brings us to our current journey, which is the .NET Jupyter notebooks. Why did we build the .NET kernel? Well, we had a company investment in data science tools, with the .NET team investing in .NET for Apache Spark, as well as ML.NET. We also began to see a growing interest from the .NET community to have a .NET kernel. And before we embarked on actually building the kernel, we made sure to learn from the community members in Jupyter who we knew, as well as listen to our customers. And I've pulled a couple of customer quotes from our user studies. We noticed a popular trend as we began to talk to our customers. They wanted language interrupt and being able to use the right language for the task at hand. They wanted to be able to leverage Python and JavaScript libraries while still using C#. But for a lot of our customers who are software engineers, they wanted to be able to plug into the data science workflow within the tools that they were familiar with. So the goals of our projects were three. One, we wanted to make sure that we worked with the tools in the ecosystem today, like Jupyter Notebooks, Interact, and VS Code. We wanted to have language agnostic code execution, which allowed people to pick the right language for the task at hand from one cell to another. And we also wanted interoperability without the need for a wrapper. We wanted people to be able to leverage data visualization libraries in JavaScript, as well as leverage popular data science libraries in Python, which is a future goal. And this is the result. The .NET kernel is a multi-language kernel and ships with C#, F#, and PowerShell support. I'll hand it over to Jon to go over the lessons we learned and our architectural design decisions.
When we create a notebook using the .NET Interactive Jupyter kernel, it has a default language. Here, Hello World is being evaluated in C#. But the kernel is always polyglot. When we choose C# in the Jupyter Lab launcher, we're just choosing a default for the notebook, but we can still use other languages. Each language is implemented by its own subkernel, and we can send code to the subkernel of our choice using magic commands like C# and F#.
Variable sharing is a pillar of the .NET Interactive design. Let's go ahead and declare a variable in C#. Now we're going to go to F# and try to share it. We're going to use the # share command. As you can see, it's also helping us to discover what kernel we can use as a source, and then we can say that we want to get the C# variable exposed to F#. Let's go ahead and see. Yeah, we got the symbol there, and let's print it out. Let's have a look now about, variables that can be mutated. We're going to declare a mutable list in F#, a list of string, another string. Yep, values there. Awesome. One value only in there. Now, as you can expect, C# and hashbang share, we're going to find out that now the F# list is accessible, and we're going to share this from F# to C#. Let's add the value, and now we're going to see what happened when we print this back from F#. The value that we change is now visible, and that's because F# and C# share the same type system, and in this case, they're also in process. Therefore, we can share the actual reference to that mutable list of string. Variable sharing becomes really important when you start crossing the boundaries between code and data and presentation. Classic things would be, I've built some data object through C#, F#, PowerShell, any other language. Now I want to go and leverage a JavaScript library to present it to my user in a form of a plot or whatever kind of visualization. So at this point, we got the need of sharing a value between a .NET kernel to a JavaScript front end. So let's start by building a .NET object. I'm going to build a collection of items. We got this object which represent a fruit type that go in my basket. Each is going to have a unit price and a quantity. Now let's see. This is how my list looks like in C#. Now let's move along into using JavaScript and D3.js to render a bar chart to show me the composition of my basket. First thing we want to do is go to JavaScript and declare a render basket function, which is going to get an SVG selector in. Now, next step, we want to bring in D3.js. So we're going to use require.js to configure how we're going to fetch the D3 module from a CDN. Now, this is the important bit now. We need a min to get back to our C# kernel and fetch out the fruit basket variable. That's where the interactive SDK comes into play. So interactive C# get variable and fruit basket. And then once we get a basket, now it's time to build the logic, how we're going to build this histogram or this bar chart for our basket. Now that we've got the function, we're going to use HTML so that we can place the item where we want on the screen. Next, let's invoke our function and use the SVG selector that we select appropriately the target DOM element to show the visualization. Now at this point, this is a polyglot notebook. We use C#, JavaScript, and HTML. But look at the fact that we declare where we want the things to be, and then we have another cell which is going to produce output above us, because that's where the rendering will go. At this point, we could really leverage the fact that we can be a polyglot within the same cells, and we can now group an HTML and a JavaScript submission by intent, in the sense that what we really want to use this cell for is to create an area and display the plot. So let's group together the HTML and JavaScript. And now this is a more cohesive and flowing experience with this notebook. Declare the object, how to render, where to render, and display.
So you've seen how magic commands are used in .NET Interactive to declare whether a given submission is F# or HTML or JavaScript. We had emulated the IPython cell magics for HTML and JavaScript from early on. Our mental model was that these were rendering shortcuts. At a certain point, though, we realized that conceptually, HTML and JavaScript shouldn't be special cases. In the .NET Interactive architecture, they became their own independent subkernels. The magics were no longer shortcuts. They were for choosing a subkernel whose functionality could grow over time, not just to execute or render code, but also to provide completion and inspection for that language. We'd now made it easy enough to add new subkernels dynamically that this change unlocked some new possibilities. Let's take a look at data access. Here, we're going to use the connect command, which allows us to add new subkernels at runtime. The extension lab package loaded at the top of the notebook brings in support for a couple of different types of database connections. We're going to use MS SQL here. And since this is going to add a subkernel at runtime, we're going to give it a name that we can use to send code to the SQL kernel. Now, the name that we're choosing is AdventureWorks because that's the name of the database that we're connecting to. And I will use the hashbang AdventureWorks magic command in order to send a SQL query to the AdventureWorks subkernel, which has a couple of roles here. It represents a connection to a specific database, and we could have more than one of them in the same notebook if we wanted to. And it's also going to dispatch SQL queries to that connection. And then we can use the Interact Data Explorer to view the result of the query. Something we learned is that the Polyglot Notebook isn't just useful for composing across languages. So you can also compose across machines or across processors. Here's a custom app for viewing map resources for the video game Doom. The app is written in F#, so we called it Foom. It embeds a .NET Interactive F# kernel as a package. Now, we're going to connect to it using a named pipe. The subkernel that's added to the notebook this time is a proxy to the embedded kernel that's running inside the Foom app. The first code submission here just loads a map into the viewer, but the next one is a little bit more interesting. It defines a custom shader using an F# code quotation, and it's going to be reinterpreted to be run on the GPU. So ultimately, what the polyglot approach is giving us is a way to compose a workflow that can access data, run code on different devices or processors, and directly use JavaScript or the GPU to do visualization. And this can all be done in one notebook without the need for wrapper libraries.
And this brings us to the end of our talk. To learn more about what we discussed here today, please visit our repo at .NET/interactive. Please let us know what you think by reaching out to us on Twitter. We look forward to hearing from you. And thank you so much for watching, and have a great JupyterCon.